This video will explain divergence of a vector field. The example is taken from 201415 question 9, where the function f x y z is equal to x squared plus y squared plus z squared over x y z. And for part A, we have found the gradient of f, which is equal to del f. Now we are working on part B to find the divergence or gradient of f. Recall that gradient of f is equal to this expression. Let's recall how to define the divergence of a vector field. Given a vector field, say f here, equal to f1i plus f2j plus f3k. Divergence of f is equal to partial differentiation of f1 respect to x plus partial differentiation of f2 respect to y plus partial differentiation of f3 respect to z. Since we know gradient of f, which can be simplified into 1 over yz minus y over x squared y minus z over x squared y times I plus minus x over y squared z plus 1 over xz minus z over xy squared times j plus minus x over yz squared minus y over xz squared plus 1 over xy times k. So divergence of gradient of f is partial differentiation with respect to x of the first term, which is here, partial differentiation with respect to x, and then second term, partial differentiation with respect to y, and then third term, partial differentiation with respect to z. Let's focus on the first term, partial differentiation of respect to x of 1 over yz minus y over x squared z minus z over x squared y. Remember that we are differentiating with respect to x, therefore we'll treat y and z constant. Now, split them into three terms. The first term is 1 over yz. 1 over yz are constant, so partial differentiation with respect to x will give you 0. And then, second term, y and z are constant, so you pull out y and z, you are partial differentiating of 1 over x squared. Same thing for third term, z over y are constant, so you're left with differentiating 1 over x squared with respect to x. Now, how to differentiate 1 over x squared, which is differentiating x power minus 2, using the power rule, you get minus 2 over x cubed. And that is how the second term is minus 2 over x cubed. And the third term as well is minus 2 over x cubed. Try to find the common denominator, which is xy x cubed. Then the numerator becomes 2y squared plus 2x squared. And the denominator is x cubed y z. Now let's focus on the second term, partial differentiation with respect to y of the blue portion, which there are three terms there, so this is equal to, then you split them into three terms, and since we are doing partial differentiation with respect to y, we treat x and z constant. So the first term, you can take out x and z and do partial differentiation with respect to y of 1 over y squared. And then second term, since x and z are treated constant, so the partial differentiation gives you 0. And the third term, x and z are constant, pull out, so you partial differentiation of 1 over y squared. Using the same method we had before, partial differentiation of 1 over y squared is equal to minus 2 over y cubed. The center term, second term give you 0, and then the third term minus z over x times minus 2 over y cubed as before. And then because try to find the common factor, which is xzy cubed. So xzy cubed, and then numerator becomes 2x squared for the first term, and then the second term, ignoring 0 now, you have xzy cubed, and then you have numerator becomes 2z squared. So I made a mistake here. This one should be a no negative sign here. So the answer is equal to xzy cubed times 2x squared plus 2z squared. As for the third term, partial differentiation with respect to z of the green part, we split into 3 terms, and you keep x and y constant. For the first term, you pull out x and y, so you end up partial differentiation of 1 over z squared. For the second term, pull out y and x, you end up partial differentiation of 1 over z squared with respect to z. And the third term you get 0 since x and y are considered constant. And so after differentiation, the first term gives you minus x over y times minus 2 over z cubed like before. And then second term you get minus y over x times minus 2 over z cubed. Now the common denominator is xyz cubed, so the first term becomes 2x squared over xyz cubed. The second term becomes 2y squared over xyz cubed. So add up, you get xyz cubed over 2x squared plus 2y squared. Putting them together, we have the first time with 2y squared plus 2z squared over x cubed yz. The second term is 2x squared plus 2z squared over xz y cubed. And the third term is 2x squared plus 2y squared over xyz cubed. And that will be the answer for the divergence of gradient of f.